I'm here to talk to you all about building the next internet, the open interoperable internet of agents, and it was very nice to hear the speakers in front of me actually refer to the need for why we need something like this. So Ranjan mentioned how we need to have semantic communication between agents in order to have truly working multi-agent systems. She mentioned the need to have multi-agent systems that can collaborate and all of that. So this is the world that we are moving towards, and I think it's very appropriate. We are here in the frontier stage. This is the new frontier of agentic AI, and more particularly, multi-agentic systems. So I'm going to skip through some of the slides here because I know for this audience, it's probably, the need for agents and so on is probably, old hat. I don't need to belabor the point. But let's talk about why do we need a new internet? I get this question a lot. When I talk about the open interoperable internet for agents, it's like we already have an internet. Isn't that sufficient for agents to communicate with each other? After all, at the end of the day, agents are just software entities, right? Why can't we just use the internet we have? Well, the reason for that is agents are substantively different from the kinds of software entities that we know, whether it's physical machines, virtual machines, containers, microservices, APIs, what have you. What we have today, the behavioral is largely deterministic. And with agents, we are moving, there's going to be a fundamental shift to move from deterministic behavior to probabilistic, non-deterministic behavior. And that leads us to a need for new primitives, new foundational technologies that can enable this kind of communication, this non-deterministic, probabilistic communication to happen in a way that's secure and reliable. So we need to have new ways for these agents to be able to discover each other, to communicate with each other securely and reliably across frameworks, across platforms. And again, one of the former speakers, Debo, mentioned we are going to have a fragmented, heterogeneous type of deployment models. There's going to be agents running in the cloud, agents running on-prem, and all of them need to be able to communicate with each other. And not to mention, the agent communication is kind of somewhere between. We know how to do, obviously, we know how to do human-to-human communication. We know how to do human-to-machine communication, and we know how to do machine-to-machine communication. But the agentic communication kind of has attributes of both human communication in the sense that it is non-deterministic, probabilistic, natural language-based, multimodal, all of that. But at the same time, in terms of the scale, the speed, the ephemerality of agents, it's close to machine. So you have machine speed, scale, ephemerality combined with human attributes of the types of communication. And all of this is what leads us to the need for this new internet. And so what we are seeing here is really something that is layered on top of the internet that we have today. So a semantic and syntactic layer, and again, the NLib thing that Ranjan talked about earlier, and the semantic communication that kind of feeds into this need for a true semantic layer that sits above the internet and enables agents to talk to each other. And that's what we are building towards. So without further ado, I'm going to skip past the slide. This just talks about a number of different use cases that you can see. And maybe I'll talk through this just for a little bit. We are talking here about common use cases that need this kind of multi-agent system. Well, before I get into this, let me have a quick show of hands. How many of you here have built an agent? Wow, nearly everyone. This is a great audience. How many of you have built a multi-agent system? Wow, this is great. This is really a great audience. Now, that is unusual. So what I'm talking about here, and I'm not going to ask for another show of hands. I think many of you have built multi-agent systems, but typically a lot of the multi-agent systems being built now are typically built within a single framework. And that's because, that's just the ease of how to build it. However, what this slide is talking about is common scientific and business use cases that need agents that are built across multiple frameworks. Agents built on LangGraph, agents built on AG2, agents built on Llama Index, all having to talk to each other to solve a common problem. And this goes from very well understood domains, right? You can think about like an IT app deployment scenario. And for that, this is something that's very near and dear to us. We are Outshift, we are part of Cisco, we are an infrastructure company. This is something that we do. This is our bread and butter. Very well understood domain. And yet, even in this domain, when you think about the end-to-end problem that you have to solve, all the way from the service ticket, which may be dealt with by an agent that's running in ServiceNow, having to talk to an agent that has the customer data for that particular issue, which may be an agent running in Salesforce, and then those agents having to collaborate with agents that know about your physical infrastructure, your network data, your security data, your observability data, all of that, which may be from agents built by Cisco and running on the customer's infrastructure. So all of them have to come together to solve this problem end to end. And similarly, there are other domains, emerging domains like drug discovery, which are powered by agents. And there you have agents that are like general purpose large language model agents, from people like Anthropic and so on, talking to agents that are trained on drug discovery data, and maybe even talking to embodied AI agents that are running physical robots that conduct experiments. So again, the meta point here that I'm trying to make here is, you have agents that need to communicate. Oh, wow, I'm already at, so I am running out of time. So this is the collective that we've built, AGNTCY. I'm very happy to say that a couple of the former speakers are in this collective. So we have IBM Red Hat. It is AGNTCY, AGNTCY. A lot of industry backing for it, a number of startups. I have and it is part of, as of this week, it's part of the Linux Foundation, so it is fully open source. We are on GitHub at agency.org and also on github.com/agency. Please go check us out. I was going to go through the architecture of what we have built out, but suffice it to say, I won't have time to get through this entire diagram. But this represents all of the different stages in an agentic life cycle. So all the way from a common way for agents to talk about themselves, to advertise their capabilities, their skills, et cetera, so that other agents can discover them, how that can show up in a directory where humans or agents can go discover what's out there, what the capabilities are, how they can be stitched together and allow communication again at that semantic layer, so that agents built on different frameworks, on different clouds, on different platforms can communicate and be understood. And then how all of that can be deployed to your cloud infrastructure with a messaging layer that is optimized for agentic communication. And again, agentic communication has a certain shape to it, if you will. It is multimodal. It needs to be very low latency because there may be a human in the loop. But at the same time, there's large state exchange that needs to happen, one-to-one, many-to-one, many-to-many, et cetera. So all of those communication modes are supported by the messaging layer that we have built out. Again, all of this is open source. Again, another slide that gives the architecture in a very simplified way. This also talks about some of the other pillars of the architecture. There's the identity piece. Again, I could go on that for a long time. There are very unique challenges posed by agentic identity. There's, of course, the identity of the agent itself. How do you describe that? What is the agent allowed to do? But then there's also the principal, the human on whose behalf the agent is acting. And that human has an identity and what the human is allowed to do. And all of that needs to come together. On top of that, agents are autonomous entities. They typically carry out a multitude of different tasks. And depending on the specific task that an agent is performing at any given time, what they are allowed to do may be different. So you have this tuple of agentic identity, the identity of the human principal on whose behalf the agent is acting, and then the task that the agent is performing at any given time. So all of this needs to come together when you talk about the life cycle of an agentic identity. So that's something that we've considered as part of the agency. There's the big vexing problem of observing and evaluating agentic systems. Now, when you talk about, again, I talked earlier about the fact that why do we need a new internet for agents? Because agentic behavior is fundamentally different. They're deterministic. They're non-deterministic. They're more probabilistic in nature, et cetera. What that then means is you need to have strong observability around these agentic systems to ensure that Are these agents doing what they're supposed to do? Are these multi-agent systems actually doing what they're supposed to do? Conversely, are they doing something they're not supposed to do? So all of that, so we have observability and security primitives built into agency as well. I will leave you with this. I know I'm at time. Agency.org, please go check it out. There's a lot of code, all the stuff, the architecture that I described, the code that's behind it, the specifications, a sample reference application that will let you build multi-agentic systems in a true, standardized way using these standard primitives that we've built. It's on. And with that, I will wind up here. Thank you very much.